We're here today to address a critical topic, securing the very future of our digital currency. We're not just talking about incremental upgrades. We're going to outline an emergent, serious risk and present a clear, actionable path to long-term resilience.
So let's start with the fundamental premise of this entire discussion. It's this stark reality right here. The cryptographic standards that protect literally all digital transactions today, well, they're on a collision course with the power of quantum computing. This isn't a question of if, but when. The time to architect a new layer of security is right now.
Now, we have to frame this correctly. This isn't some distant academic possibility. We need to look at this as an existential risk to the integrity of our entire financial system. And the threat is active today, even if the full decryption capability is still on the horizon.
Let me explain the specific nature of this threat. It's a strategy known as harvest now, decrypt later. Right now, as we speak, adversaries are capturing and storing vast amounts of encrypted financial data. Now, they can't break that encryption yet, but they're banking on the future. They're waiting for the day quantum computers are powerful enough to do so. What this really means is that every single transaction we process today using our legacy systems is a potential future vulnerability.
That threat, however, is not insurmountable. Not at all. The solution just requires a fundamental architectural shift. And that's exactly what we've developed with GVE's Provisioned Trust Infrastructure.
PTI. You'll hear us use this term a lot. It stands for Provisioned Trust Infrastructure, and it's a security architecture that was built from the ground up for the post-quantum era. And here's the crucial point. It is a post-PKI system. It doesn't just put a Band-Aid on the existing public key infrastructure. No, it replaces its core vulnerabilities, which makes it inherently resilient to the very attacks we've just been talking about.
So, how does it work? Well, a key technical differentiator is our approach to key management. You see, traditional systems use predictable algorithms to generate keys. Our GVE system, on the other hand, uses a randomized generator. There is no algorithm to crack or reverse engineer. Think about what that means. Even if an adversary could somehow compromise a single session key, that knowledge would be completely useless for accessing any other key or any other transaction. Any potential breach is automatically and instantly isolated.
On top of that, the architecture guarantees data sovereignty by design. Sensitive KYC, that's Know Your Customer data, it never ever leaves the local bank servers. It's never in transit across the network. Now, this isn't just a nice-to-have security feature. It is a direct guarantee of compliance with the most stringent data privacy laws out there, like GDPR.
So, how should you conceptualize this whole system? Let's use a simple analogy. We want you to think of our quantum-safe infrastructure as pristine pipes. Perfectly secure conduits connecting financial institutions. And through these pristine pipes, our real-time gross settlement system provides the liquidity, the value itself, which flows instantly and, most importantly, safely from point to point.
Now, this integration into the existing financial world isn't some proprietary black box. It's built on established, global standards you already know. We're using ISO 20022, which enables continuous, 24/7 real-time settlement. We have ISO 24643, which provides the standardized API gateway for seamless interoperability. And our modular architecture ensures we can securely connect the entire ecosystem, from central banks to commercial banks to electronic money institutions.
Of course, any new architecture like this is going to face scrutiny, and we believe it's absolutely essential to address the market's valid criticisms directly and with full transparency. So let's do that now.
Okay, here's a primary criticism we hear. That new digital currency designs don't really offer anything that private solutions don't already provide. It's a fair question. And our rebuttal is very direct. Those legacy private solutions, they're all built on the same vulnerable public key infrastructure we've been talking about. GVE, on the other hand, provides two unique, frankly non-negotiable layers of added value: true quantum-safe security and guaranteed data privacy by design. These are critical features that existing solutions simply cannot offer. Period.
The second major criticism we often see centers on perceived complexity and cost. People think it's going to be too complex and too expensive.
Well, actually, it's quite the contrary. GVE is designed to reduce both. By consolidating multiple roles into a single digital operating system, we streamline the entire payment value chain. And what's more, our CBDC as a service model allows all the participating institutions to mutualize, or share, the investment and the ongoing maintenance costs. That leads to very significant savings across the board.
All right, let's put this into a direct comparison. I want to be clear. The differences between legacy systems and the GVE architecture are not incremental. They are absolutely fundamental.
Just look at this table. It makes it crystal clear. Let's start with the quantum threat. Legacy PKI is completely vulnerable. GVE's PTI is immune. For key management, legacy systems are algorithmic and therefore predictable. Ours are non-algorithmic and randomized. On data privacy, legacy systems send your sensitive data across multiple points of failure. We ensure full data sovereignty, keeping it on local servers. And finally, system complexity. Legacy systems are high, they're fragmented. GVE offers a streamlined single operating system. The contrast really couldn't be starker. Understanding the solution is one thing. Implementing it is another. So we've developed a clear, time-bound action plan to demonstrate feasibility and, frankly, to build confidence that this can be done.
We propose a straightforward 12-month pilot. In the first 3 months, we establish a joint test environment with key vendors. By month 6, we'll integrate our API gateway with commercial bank test systems. By month 9, we can begin carefully phasing out legacy PKI layers in non-critical components. And by the end of the year, we conduct a full pilot review. This is a practical, phased approach to adoption. It's entirely manageable.
Ultimately, this is not just a technical upgrade. Let's be very clear about that. Adopting this quantum-safe, cost-efficient, and privacy-preserving architecture is the necessary strategic decision we must make. It is how we guarantee the security, the integrity, and the future utility of our nation's digital currency.